This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi. So I told my daughter the other day that I could not talk and start the slideshow at the same time. And she said, "Oh, you're really getting old, Mom." So it is a Wednesday, July 11th, 2025, and we are in our summer book club today talking about tangrams and transformations. I like the alliteration there. I don't think it was planned. Just a reminder that we are working 2 booklets per week with the assistance of our mentored tutors, Jill and Babs. We are reviewing the published instructions to help you understand how to play the game as published, but we're also exploring ways to adapt the activities and the games that are in the booklet. Summer is a perfect time to continue practicing our math skills, but doing so in a way that is a little bit freer, perhaps, to our students. I actually read a quote recently that talked about how much more effective games were for learning. And it turns out that the quote was really one of those quotes that ends up on the internet without any backing. But in researching the quote, there is a lot of research, a lot of published research that talks about how games are really an effective way to help children learn. So these activities are not just for the summer, although that's a perfect way to use them. They are year-round activities. And I had a question the other day from somebody talking about, right, is the best thing to do to get all 16 pages done? And right, we keep saying this, that there's no right answer to how much or how to structure your math map day. That one of the goals of the math map was to create a curriculum that is very tailorable to your family. And so that may mean adjusting the number of lesson pages you do and including more activities if you have students for whom those work well. So I just really continue to encourage our families to embrace the freedom that they have to tailor their math education in their home. And we know that that may take you a little while to really embrace that freedom, but I just wanted to encourage you to do that. So with that said, I am going to turn it over to Jill, and she is going to talk about Tangrams.
So, tangrams are things that most people are a little familiar with. I mean, to somebody, you always have your first time using tangrams, but for most of us, especially if we have multiple children or if we did them even ourselves as a child, they're a little familiar to us. Or maybe a lot familiar to us. Another thing that looks very simple, it's big, it's friendly, it's bright, but not everyone is automatically a tangram brain. So to just give ourselves a little bit of grace, you know, when we're working with ourselves or our children, and realize that some kids might just snap it up and they just seem like they can do them all right away, and other kids, there's nothing wrong with how they see math. They're intelligent, bright students, but maybe this just is a little more challenging for them. So it does look friendly. It is very accessible. It is familiar to most of us, but that doesn't mean that all of us are going to do it with no frustration. Um, the way we can avoid that frustration is, as usual, that we set an environment that lets them feel free to play, to experiment, to practice with it, and that we don't have to be perfect at it either. So the idea here, according to the directions, is that you can copy the back cover and cut out all the shapes. That in itself can do lots of different things. You can make it bigger, you can make it smaller, you could do a whole set on green, a whole set on yellow, a whole set on blue, and then give everybody one of each color so that they all have a set that looks like this. Or You could give everybody their own, like one person has the yellow set, one person has the green set. Which then means that maybe cooperatively we build some of these because we can take turns and put our pieces in. Um, and also it can be nice to have it on both sides, to have the colors on both sides. So that's one of the advantages to printing it on a colored paper, is that then when you flip it over, you have the same color. It's not white on the back. You're going to rearrange the shapes to make the different images shown at the bottom of the page. Image of a rocket is an example. And so that one already has the pieces built into it. So kind of like number knockout, you have to use all your pieces. You don't have leftovers. So just realizing that all those pieces do fit somewhere, and looking at what they have here, a great way to practice would be to copy that, to see the image that's already filled out and then practice copying that on the table next to it. Or if you buy large ones that are actually Tangram size, you can lay your pieces right on top of it. Okay, and then we see the rabbit, the fish, and the person. There are whole books of Tangrams. On the web, there's a whole bunch of puzzles. You can make your own. You can get them from the library. Some of them are like the rocket, that they already have the shapes and the pieces shown to you. So that's great for our earliest or most unfamiliar people, or for grown-ups who want to just sort of model that and not have to do all the Tangram sets the same exact pieces shown? Yes. To my knowledge, every Tangram set I've ever worked with in my whole entire life or bought for my kids at home, they all have 2 large triangles, 2 other small triangles of the same size, a medium triangle, a square, and a rhombus, all of them. So you should be able to, if you ever have them on sale at the dollar store and you want to pick up a few more so you don't have to, because my first book, I tore the back off. And so I was glad to have another year coming. So I wound up with a back on my book again, because I skipped reading the directions, because we're like, oh, I know what to do here. So it said copy. It didn't say tear your book apart. So the Tangram here, when we look at this, we can think about our children that maybe would seem to be drawn to this rather quickly, or would not seem to be drawn to this rather quickly. With our youngest students, one of the things we can do is just go back to those 5 core habits. We can name the shape, we can name the color, we can name if it's big or small, we can name how many sides it has. There's so many things we can do just attending to the actual pieces. And then we can look at memory. Do we know any foundations rules about any of these shapes? Do we know some perimeter, some area? Do we know anything about triangles? Do they make, how many degrees are all our sides equal to? How many degrees on our squares? So it can even be just a little bit of learning or review. And then we see here that they used expressing to express these pictures. So we can copy those, we can make our own. And then the storytelling, you could make up a story even about the rocket, especially if they really worked with it. Yes, finding the area would be a great way to make it more challenging for our older students. And the perimeter, and this really goes along very well to the previous book. I think it was honestly, Kirsty, you'll have to say for sure. I feel like it was the Polygons booklet where we talked about, it doesn't matter which booklet, about that you can add shapes together.
It's this booklet, 17.
It is in 17, this booklet. So that's why it's so perfect for this booklet. Look at that. Also, I was looking earlier at the art on the cover of this booklet, and they could make their own art. They could just lay them on the table and add other true pieces, rubber bands or paper clips, and talk about what shapes they have. So obviously that's not playing the Tangram intent here, but it's ways to include our younger students and let them just play with the things that we have. We can use the ruler and estimate the area. So, not necessarily being precise, but just, okay, this is about, and lay it and moving it. Those are all really, really great, strong skills to be able to do. So this travels well. this, you can, like I said, you can copy it, you can put it on cardstock, you can keep them in little Ziploc bags, each one. If they get ruined, it's really not a very big deal. You can find lots of the shapes to make online so that you can find them on your phone. You can give them challenges. If you found magnetic ones, it would be a super road trip activity for your younger students. And then again, still bringing in, that's a great time when they say, triangles. All right, let's review. What's our area of a triangle? Those kinds of things that we've learned. What are your ideas as you were watching this? So, yes, I know what you mean. I know what you mean, Kristen. I have felt very Tangram challenged. One of my sons, he can just about do any of them without even having to, he's very spatially gifted compared to some of the rest of us. But if I look at the piece, so that's something we can do. If we find the ones that also have the answers, and that show the pieces, just lay them on top and then maybe get a copy of one that doesn't have it laid on top and see what we can do. And it's kind of like, how when we're learning how to use Legos, or we're learning how to use measuring spoons, or we're learning how to pump gas, whatever we're doing, when we start to practice with it and just say, okay, I realize that this works well, then to use that same skill over and over. So when we see it's going to be wide or it's going to be narrow, what can I do? And if we have the practice of building a long piece, or the practice of building something that's very symmetrical. So the more we practice with that, and doing the same shape over and over is worthwhile. Just kind of, not that we want to memorize what it looks like, but getting the feel of how those fit. Because what's to me particularly challenging about the rocket is that the two legs, if you saw it in all black, they are symmetrical. But when you see it this way with the color, it doesn't look like it because the yellow is so large. And then that dark blue is small, and we have the red and the lighter blue, but it really is symmetrical. So sometimes it feels a little odd. So that's another reason to make this in several colors. You can mix and match them, or you can just have one whole set. You could, if you wanted to make it a game with your family, you could pick one out and try to build it in the middle and have each person add one piece at a time and see if you could do it. You could race. You could have a couple of them working on it together if they're on even ground with this particular activity. So again, what are some ideas that you all have? Love to hear from you.
I like when you talked about the magnetic ones, because I think when my kids were little, they had like a little tin box and we took it in the car. And so that tin box had the magnetic tangrams. And so they didn't fall or move around, as easy. And they could just do it whenever they wanted. And that was really cool. It did have little cards, so they could look at the card and then try to recreate it. So there's all kinds out there. But one idea you kind of touched on it was, you know how we used to play this weird game in Essential, or maybe it was Foundations, like a review game. If they got a question right, they would build this person on the board. They would like draw this person. So I was thinking, if you wanted to do some kind of review game, like have them, I don't know, some of your flashcards maybe, and then whoever gets it right, they could start building this creature or whatever kind of design. So kind of incorporating some of the, notations cards or something that you want them to drill, then you could still practice this part and then you could still, drill. So kind of like combining two things into one.
Yeah, that's a good idea.
Three things that came to mind as you were talking, Jill. So first, this is really not for your students, but just an interesting point, that our eyes actually respond more to area. So when you talked about the yellow having the greater area and that capturing our attention, and that's one of the reasons why when we do bar graphs and histograms, it's so important that their width is the same. Because if my bar graph, if one is wider and one is skinnier, we won't just look at which is higher. We'll actually look at that area. So anyway, a complete aside, when you said that, it made me think of that. The second thing that I thought about when you talked about estimating area, I love the fact that you said you were going to estimate the area by measuring with a ruler. And that made me think that this is an opportunity if you have students, especially your high school students, and you want to go back and practice significant digits. That's
Mm,
exactly when we would use significant digits, right? Is in
yes.
measuring. And if my ruler, right, whatever your ruler measurements are. So, like this one happens to be measured in tenths. So I could measure to the hundredths, but I can't measure to the thousandths or the 10,000ths place. And so, exploring with our students, actually measuring something, talking about how accurate can you be or how precise can you be with your measuring instrument and how would that affect our measurements um, would be a way to take something from 1D that we talked about and bring that into a practical application. And then the third idea that I had was when you were talking about how some of us maybe struggle with tangrams, that we don't necessarily see it. It's easy for those students to not want, right? It's a game. I don't have to play that game because I'm not good at it. It's really hard for me, right? And we tend to avoid that. And so I was thinking, what are some ways that you could encourage those students to do this? Because that's we're only going to get better, right? If we practice, right? So how do we get better at spatially seeing things if we don't practice? And so I thought, well, what if you had like the puzzle of the day and you could just stick it on your fridge, stick it on your counter, and hey, everybody work on this by, and if everybody gets it by the end of the day, you get sprinkles on your ice cream, something like that over the summer, right? So you could have a puzzle of the day so there's just one.
Yeah.
And then if you made it where, hey, once we all do this, maybe before noon, they're supposed to work independently. After noon, they can work collaboratively. You could set up all kinds of rules for it in your home. But for those activities that maybe students don't want to sit and focus on for half an hour because it's overwhelming, something like that, where you say, hey, you've got 12 hours to work on this, right? Just
Hmm.
come back and keep playing at it. But we're going to do it every day. Maybe a way to take some of the pressure off. So anyway, just some thoughts.
I like that. I like that a lot. You could even do that on vacation, while everybody's waiting, because, there's always somebody who isn't ready when it's time to go to the restaurant or to the beach or to bed, whatever it is. And, everybody's still waiting. And then this is an easy thing to just have out on the coffee table. It doesn't take up a lot of space. And you could even take it to a restaurant and it can be something that they do while they're waiting. If you don't mind, and just make them disposable. Just copy new ones. It's really, yeah.
I wanted to add, if you can you hear me?
Yes.
Yes.
Okay. Yeah, so I wanted to add that um, if your children are struggling with the patty paper, like I'm talking 4, 5, 6, 7 year olds, maybe older, um, because one of the things we're doing with patty paper is using the patty paper to determine is it really an acute, obtuse, or right triangle or angle, I mean, and also folding the patty paper. Well, if you have a hard set of these plastic tangrams, a child whose fingers maybe aren't so nimble with the paper could be doing some measurements on the paper with the tangrams, or use the tangrams to practice drawing on the patty paper. So I just wanted to give that other suggestion for different lessons.
That's a great idea too.
Yeah, because if you buy that patty paper, there's like 1,000 sheets in the box. So it could last you years. And so if you want to come up with other ways to use that patty paper besides that 1 week we use it.
Yeah. I mean, honestly, just keeping these in your math supplies for many of the lessons would be pretty great. Just to always be able to pull that out, visualize it, use it in the different draw draw inscribed and circumscribed circles around them. Look for other things in your house, like a mason jar lid. Does it fit inside or out? Yeah.
So speaking of that, what a perfect segue from tangrams to transformations. Take it away, Babs.
Okay, so I guess this week I got the hard one because Jill has always gotten the hard ones, and so it's payback this week because I got the hard one. Um, and really, I don't think necessarily the all the concepts are hard, but I think trying to figure out how to show you the concepts was probably more difficult than actually doing them. So we'll kind of read through the directions and then we'll kind of look at the backs. So these are, we're talking about our transformations. And I think one thing that really helped me, because Kirsty kind of pointed me to this chart in our transformation booklet on 18.2, this is a good chart that talks about all the different ways you can translate and reflect and rotate and dilate. And so I kind of kept that to the side as I was looking at these to kind of refresh my memory. So I liked the way this chart kind of lays it out. So if you have that chart, that might be a good one to kind of pull out and look at while we're looking at these things, especially if they're unfamiliar and we need kind of a refresher about what the definitions are and that kind of thing. So to start off with, we just roll the dice and then use those numbers as our points. So I just kind of randomly had numbers. And so I rolled a 1 and a 2 to get my first two, and then a 4 and a 4, and then a 5 and a 3. Okay. And so once we have these, then we're going to plot them and make our triangle. And so that's on the next slide. So once we have those in a triangle, and so I cheated. I used Desmos. If you've never heard of Desmos, it is an amazing website that lets you play around. This one is actually called desmos.com/geometry. So you can just use regular Desmos for lots of things, but this one, if you like to draw shapes and that kind of thing, it helps you, maneuver them. So if your kids love like, playing on, with the shapes and that kind of thing, I think this website's really cool. So this is plotting the triangle first. And then we're going to try to take this triangle and do all the things. So all the things that were on 18.2, we're going to do. So the first thing they want us to do is to reflect the triangle across. And so what I loved about doing this on Desmos is that it did it for me, but then I could look at it and I could see the pattern. So you can, you guys can look at it and tell me, well, what is the pattern, right? What is different about the right side than the left side? Well, that first point is negative, right? That's really the only difference in those two. And so I liked being able to see this in that way so that I could see the patterns. And kind of going back to the tangrams, if you have younger students who maybe are not at this point of calculation, you could just take your tangrams and reflect them over, right? And so if you still have those tangrams out, you don't have to necessarily practice this kind of calculation, but you could. So it's really up to you and the level of your student, how far you want to go. So that was the first thing to do, was to reflect the triangle across. And then the second thing they want us to do is to rotate the triangle clockwise and counterclockwise. All right, so that's on the next slide. So Kirsty, can you see where you can play a video? Yes. Okay, look at that. So this really shows us how it goes clockwise and counterclockwise. I think that is super cool, right? I love the animation. And so after this point, I think it slows down a little bit and it shows you, okay, now I'm at 90. All right, and then it'll go a little bit further and it'll show you, okay, now I'm at 180. And then it'll go a little further and show you, okay, now I'm at 270. And then it'll go all the way around and show you that it's at 360. So I loved watching that because that kind of puts things in perspective, right? As we're playing around with that. So again, if you love that kind of animation, and I do, a lot of kids I know just love to play around with it and make things. And then, this website's really cool because you can actually, grab that triangle and tell it to reflect and tell it to rotate and tell it to dilate. It took me a couple of hours to figure that out, but I finally figured it out. So, so if you're interested, that's something really cool to kind of show the kids. So again, if you have younger students and you want to just use the tangrams, right, you can still do that with your tangrams instead of, working on on it in this way.
I just
All
have
right.
to say that I'm super excited when you use the lingo of dilate, reflect. I know what that means now. So yay, celebrating that today.
Yes, yes, that is very cool. Yes. It makes us feel good. I mean, people talk about the first time they look at the naturals and how do you expect me to teach this to my kid? I don't really know any of this stuff. But when we are learning with them and we're modeling that, hey, we don't know everything and we are, learning along with you, and then they get to see us celebrate what we've learned. I mean, I feel like that helps them continue to be motivated. Like, how old am I? Like, I'm 40 something. I don't even remember, 48, 49. And I'm still learning math every single day, right? I'm still learning something every single day. So I feel like we as adults are not getting to a point where we're just going to stop, right? We're always continually learning. And so I think that's good to model that for our kids. Okay, so this was the one that tripped me up a bit, but Kirsty was able to help me. So the next one in our booklet talks about transformation, and it talks about how we can name the vector. No, no, this one's first. What is this one first? This one is dilating. Okay. So when I think of dilate, it helps me think of like going to the eye doctor about the dilation, how your pupils get big and small. And so, but this is a good picture to show. And I think, was it Kirsty that was telling me that to calculate these, you just multiplied it by the factor. And so they tell us in the directions, they want us to they want us to dilate it by 0.25, by 0.5, and by 2. So that's what I did in each one of these. So the top one is the 0.25, the second one is the 0.50, and then the last one is 2. And so I like the visuals again because you can do a lot using those skills of comparison. Ask your students, what do you notice that's the same? What do you notice that's different? Right? And those kind of things. So this one wasn't too bad. And then the last one, I think, is the one that kind of tripped me up because it was talking about translation, but they were talking about naming the vector. And so and Kirsty will probably have to jump in, but what we were talking about is if we start in this upper right quadrant, then the first thing we did was we found the farthest point away from the axis, and then that was our starting point, and then we had to cross the axis, and then once we did that and it translated and it slid that triangle over, then we have to kind of calculate the vector. And so Kirsty, you might have to help me with this part. Is when we found the vector, it was just how far we were moving across. Was that right? Okay. And so then we did the same thing. We were in the upper right quadrant, but we went down. And so we did the same thing. We just slid down, and then our vector was how far we went down. Then this one was a little tricky because not only are you having to go across one axis, now you have to go over the second one, right? You have to go over the X and the Y. And so our vector was like how far we went over and then how far we went down. And so we were adding those two together. So again, if that kind of calculation is too difficult, then you could let your kids, use the tangrams and just slide them over, or look at the ones already done and do some comparison, right? Talk about which quadrants they're in. Use some of that vocabulary because a lot of our students, this is the first year they're learning about the quadrants. And so making sure they understand where 1, 2, 3, and 4 are. And then just talking about, well, what's the similarity in the points, right? And they could even count how far it went down, how many blocks it went down or how many blocks it goes across. Um, so, so
what,
I love, oh, go ahead.
I just had a quick question. So what would for the upper left picture on the screen where it's in quadrant 2,
Mm-hmm.
what would be the vector? How would, it says name the vector. So what would the vector be named?
You want me to jump in, Babs?
Yep, I would love it.
So remember that that our vectors, especially when we write them in a rectangular form, we're going to have a horizontal component and a vertical component. So if I want to move from the first quadrant to the second quadrant, do I need any vertical component? Do I need to move it up and down? No. I could. There are some limits on how far down I can go, but I could move it up and down, but I don't need to. All I need is that horizontal part. If I want to make sure that all of my points get into the second quadrant, that's where Bab said, we've got to look at the one that's farthest away, right? So I'm going to look at this point that's farthest away, because if the one that's farthest away from the second quadrant gets in there, all the other points are going to get in there too. Does that make sense? So if this one is at 5, right? 5 is between 4 and 6, not 7. So if this is 5 units away, then I have to move it at least 5 units. So my vector is going to look something like this, where my vertical component is 0, and whatever goes here, right, has to be, it has to be at least 5 units, right? Well, really more than 5 units. And it's going to be opposite that, because I want to move it left, right? So I'm going to just put H here, and I'm going to say that H has to be less than the opposite of my coordinate, which is 5. So it could be -5, it could be -6, it could be, well, it couldn't be -5 because it's less than, but it could be -5.5, -6, -100. Anything that is less than -5 is going to make sure that all of those points slide into the second quadrant.
And that's one thing I asked her too, Kristen, is so you're basically saying it's not just one right answer. There could be multiple answers. And so that, because that's where I think I was getting confused. I was thinking, well, there has to only be one right answer, but she was saying, no, actually, there could be infinity answers.
Okay. So that example is just like it just happened to stop at -2, but it could have stopped at -1, or it could have
Mhm.
stopped at -1/2, because that would still be in the second quadrant, but all points are in the second quadrant still at that location of the back end
Yeah, because
location.
as long as it's less than -5, right? So it could be -5.0000000001, and it's still going to be in the second quadrant, right? So there's a good thought activity with our older students, right? Is if it's not on that axis, it's in the second quadrant. It doesn't have to be far over into the second quadrant, right? So anything that's less than -5 is going to work. So if we looked at it vertically, right? So this is 4. So I have to go at least 4 units down. So I'm not going to change my horizontal. Whatever my vertical is, I'm going to say has to be less than, in this case, -4, right? It's got to be less than -4. As long as it's less than -4, I'm going to make sure that it's down in my second quadrant. And then
Perfect. Thank you so much.
if I add those two vectors together, right, you see that if I go left more than -5 and down, or left more than 5 and down more than 4, I'll end up in the fourth quadrant because I can add those two together.
Kirsty, just to clarify, so that if people watch this in the future, the -5 in where the H is, that's not
Yes,
its new point. That's how far you're moving, correct? So
correct.
the image that we see here would be an
Oh,
8, it would be a -7, a vector of -7, 0. Is that correct?
no, no. Well, in this case, yes. So
Okay,
this is in this case, yeah, this would have
okay.
been -7, 0. Yeah, the
Because
actual
it's how
vector
far it
there.
moved.
Yep.
Yes, okay. I just wanted to make sure that anybody, if they watch this in the future, they don't think we're renaming a
Yeah.
point.
And so, and that works, right? Because -7 is less than -5. So here it went 4, 5.5, right? So here my vector was actually -5.5, and -5.5 is less than -4, so it works. So can I just say that one of the things that I really loved about what Babs did, and Babs, how many years have you been doing the math map now?
6.
6 years. Okay. So Babs has been doing the math map with us for a few years, and she's seen some things. But she's demonstrating here that she has learned the grammar, she knows what all the words mean, she can do the exercises, but this was a whole new way of thinking about things. And so she said, okay, well, I'm going to dive deep. And what she did was, I'm going to create patterns for myself. And so in the chart, there are rules that say, this is how you do these transformations, right? Well, Bab said, I'm going to go. And I love the fact that you were saying when you look at the reflection, you could create all of these examples and see the abstraction. That's the difference between being a grammarian and becoming dialectic. So Babs is demonstrating to all of us that she is using her skills of learning to create extra examples so that she can look at a pattern and she can create for herself learning. So instead of saying, oh, the chart says that I just do the negative X value when I reflect across the Y, right? That's one level of learning. Babs took this to a whole new level and said, I'm creating this example so that I can see the pattern. And I go, oh, that's all I had to do. And so I just really wanted to highlight how Babs used this tool, right, to do that, which is really great, right? I think this game um, activity is where we've had some that feel like maybe they're better suited for younger learners, and then we've looked at ways we can adapt them for older learners. This game is a great example of something that we can build to over years so that by the time our students are in challenge or maybe even in the upper challenge years, they're ready to sit down and actually do this independently. Right. And so we've talked about some of the ways that we can build to this. And the Tangrams are a perfect opportunity, right, to give our littlest learners, right? We could even, if our older learners are working on this, right, back cover and they've got the grid before them, our littlest learners maybe pull out their tangrams and we'd say, okay, everybody reflect. Well, they can just flip their triangle over to reflect it, right? Everybody rotate. Well, the littlest learners can just turn, right? Go ahead and what else? Oh, slide it, right? We're going to translate it. Just slide it around to see how it stays the same shape, right? When we move it. What about dilation? Well, we have some tangram pieces that are similar, right? So we can say, okay, start with the small triangle, find the bigger triangle, or start with the big triangle, find the smaller triangle, right? So we can take those tangrams and do these activities with them, right, without any coordinate plane. Then to step it up, they can do those same activities, but on top of the coordinate plane, right? So now you can say, okay, I want you to turn it over, but turn it over into the second quadrant or turn it over into the fourth quadrant. I want you to rotate it around the middle. So now we start doing that and we start building up this idea of how those shapes could move in the coordinate plane. And so we can slowly build our students their level of confidence in this, right? Then we can scaffold by actually giving them, right, the formulas. So, okay, we're going to tell you, here's your point. I want everybody to go and write the point with a negative X coordinate. Here's your points. I want everybody to go through, write your points with a negative Y coordinate. So we can actually give them the instructions as to how to do the calculation to do all of these translations. And then I really love the idea that our oldest students who maybe want to experiment, right, that there's a great tool here, right, a digital tool that lets them go and experiment with a limitless number of examples. In the uh, the master's math course, the basic math course, one of the things that I talk about is the the joy of mathematics is that numbers are free, right? And so I can try as many different numbers as I want to find patterns. And I can keep giving myself examples to see what the pattern does because there's no limit, right? It's not like I have to pay for every number that I use. There's this limitless number. And here we see we can do that with shapes too. There's a limitless number of triangles. There's a limitless number of points that I can go in and rotate to see, well, what does this look like? Well, what would this look like if it was a square? What would it look like if it was a pentagon? What would it look like if it was some weird complex shape, right? And so this gives me a way of doing that um, digitally. And one of the things that you can do if you have just talking about digitally, the constructions, if you have a student who is really struggling with they maybe have the idea of constructions up here, but maybe they're struggling to use their tools, don't stop practicing with the tools. But this Desmos geometry actually has the construction tools digitally, so you can go, right, and draw a circle, right, where you would use your compass. You can use your straight lines. So you can use a digital tool to do those same constructions. And so again, for those students who are ready to explore, this is another tool. I would encourage us to leave that, right? That's not where we want to start, but that's a tool that those students can use if they know, Kristen, right? You could use any kind of shape. You could start with a point, right? That would be another way we could do this, is just start with one point, right? Reflect one point, rotate one point, dilate one point, and translate one point. Then you could do it with two. Then you could do it with the whole shape to see what's happening. And that will help those students to start seeing those patterns. So do it paper and pencil, but then Desmos gives you that opportunity for those students who maybe do want to go and explore, because it's just faster than having to do it over and over yourself. So if they're really excited about this and they're looking for, how do I take this further? Right, that historically with conventional math textbooks, if you have a student who wants to go further, right, what do? You maybe go faster through the book, or you buy the next book. You don't dwell on a topic, right? You just keep churning through. The beauty of the math map is that when we say it's tailorable, it's not just tailorable to maybe make it less complex, right? It's not saying take stuff out. We can do that. We can, right, lessen what our students do in some respects, or change up what they do. But we can also push our boundaries the other way, right? So if you have a kid that's just really loves the idea of transformations or constructions, right? That there are ways that they can take and explore and dive into this. And not, oh, well, I've got this, I'm going to move on. But hey, this week we're talking about this, and I just want to dwell on this and really dive into this. And that's an opportunity we have as parents to let them do that.
So Kirsty, I want
Because
to I want to chime in here. So everybody knows we talk about the tops a lot. So this is a perfect lesson where you could actually take the 16 pages of lessons, and there's 4 problems, there's 4 graphs at the top of all of them. So that is 64 problems. And you could go ahead and Xerox if you wanted, or if anyone uses copy, handfuls of this big grid on the back. And you could do every problem on this large grid. So your children can really see the numbers that I went over 3, or I reflected 12, or I did it across y equals x. And so it's just an opportunity to not make light of the small things, because our older children are struggling with week 18, because this lesson's generally not asked of them to do until they're like in challenge 4 or college level. And anything that a child struggles with when it's small goes a lot easier if you can make it big. So I just wanted to point out, you don't have to play the games. You could actually do the lessons on this page.
Babs, I really like how you highlighted the furthermost point. And I think somehow marking that for our students is even a way to start at the beginning and not overlook the things that we see and we think, oh yeah, okay. But to highlight that for our youngest students, put a sticker on it or whatever, but a piece of ball of Play-Doh, but some way to mark that furthermost point, and then even do like Kirsty was showing us, counting. And so I think that those things, if we do them when they're young, if we do them every year when they're young, after a while, then like Lee was saying, when they're older, it won't be the first time that they've had to think those things through.
With our youngest ones too, I mean, this is a perfect, right? Make this an outdoor game, right? Make it an outdoor game where you make everybody say, okay, you know, put put two lines in your backyard, right? And have them physically move, right? Okay, everybody rotate 90 degrees. Well, where does that end up, right? Everybody move left 4 steps. Yeah, Babs, Simon Says, right? So take those classic games and remember, what are we trying to do? We're just trying to help them. One, our older students, yes, they're going to do the calculations, but for our younger students, what do we want them to understand? What's a translation? What's a reflection? What's a rotation? What's a dilation? Right? And so you can play those physically. Oh, I like that. Mother, may I? Right? So playing those, but using these words. Um, is an opportunity. Or with their teddy bears, right? Like let them have a bear and move a bear around if you don't want to be outside, right? Maybe you're playing this in um, Minnesota in January. Going outside may not work. Although I think those Minnesotans are probably tougher than I would be. So
Well, Jill brought up another good point too about the fact that we might recognize things that our students don't. And that's something that came up this week as a parent was looking at the flashcards and she was like, why do you have these? I think it was the exponents. And she was asking, why do we have them in order? Because we're basically just giving them the answer. And I was like, well, you know that because you know all of them, but they might not know that. And and maybe that answer at the bottom gives them a hint, and so it kind of helps them, right? I guess you could put them out of order, right? But what I guess what she was saying was what's on the front of the card is related to the back of the card because they're, interchanging like exponents and logs or roots or whatever. And so she was just wondering, why they were, similar. And so it just makes a good point that we might see something, but that doesn't mean our kid sees it. And they might not see it today. They might see it like 3 weeks from now or next year, right? Because we're all on different levels. And so just because we know it doesn't mean that they know it. So,
it's a really great point. Well, don't forget, we are here next week. We will be looking at lessons 19 and 20 together. So we're progressing through our year, which means that we've got about 6 weeks left, and we'll be finished with our games and activities, and then we'll be starting our next round of the book club. So don't forget, if you have any questions, especially for those of you who are watching us recorded, please email them in, and we'll be happy to address them. And are there any questions now that anybody has that they'd like to talk about?
well, Kristen asked about the activity we were doing. Do you always have to use a triangle? Can you use a
So
polygon? Any other? Okay.
yeah, and actually, as we talked about that, I think I would start with a point, just doing 1 point at a time, and then build from there.
Yeah, you can do them with the line segment. So you can do it 1-dimension shape, 2-dimension, and then 3-dimension. There's lots of opportunities.
I have a question about the flashcards. This is the fractions one. Can I ask?
Yeah.
I don't know if you, so like these card, can you see? I don't know if you can see this card.
If you turn your blur off, then we'll
um,
probably be able to see it more easily. The blur tends to blur things.
there we go. So like these kinds of cards that have the fractional, you know, and then
Yes.
the back. So what would be the, like, how would you ask a question so that the student would name the answer? Like how would you say, do you say simplify this to use an index and a root symbol? There's two of them. There's this one too that has this. I was just trying to figure out how to ask the
I'm
question for the fractions.
looking for it so that, is that exponents, roots, and logs, or is that the fractions?
Fractions.
So Kristen, some of the cards that are like that are going to feel really difficult, and they are patterns of the rule of a bunch of the other cards. And it might help for you to do the other cards that have numbers first, and then all those letters will make sense. So going from concrete to abstract can be true with the flashcards too. But then once they understand that pattern, then with that flashcard, you could use it to say, you make up the number. Now tell me what the answer could be on the back.
Okay. I just
Yeah.
didn't know if there was a way to ask
We
it,
like a
you know,
prompt.
like a
I would
like a
say, like, if
prompt.
you're talking about ones that have like the fractional here, like that card in particular, I would say express this in a radical form. Then you might have one where you say, okay, express this with, like this one, the n over d to with a negative m index. I would say, okay, express that with a positive index.
Okay, so just
Then
use the proper our words, proper.
yeah,
I just wanted to make sure that I was saying it. I'm just trying to think through how to, you know, for next, like in class, like how to ask the question, and I want to say it in the correct way. So express, and that's what I thought it was. I said simplify, but that's not correct. I think it's express this. Express. Okay, thank you.
you're welcome. Yeah, I think we've gone places that other flashcards have not. And so there's some things where we are going to have to talk about, well, what is it that you're expecting there? And Lee tried to give some hints on the back, but there may be somewhere those hints as to the prompts aren't there, and we're happy to help work through those.
Yeah, kind of, this is a foreign language, and if people don't have a peg at all with those symbols or words, the card's almost useless. So you can copy it or say it or read it. That doesn't mean you'll know anything. So as an example, an old timeline card we had was Amenhotep IV and monotheism. Well, if you don't know what the fourth means, if you don't know what monotheism is, if you don't know what Amenhotep is, the card's meaningless. So the flashcards gain value as you and the students gain vocabulary and pattern recognition. And some of these more advanced sets we have.
Is there a reason that I get the N and the D for the numerator and denominator? Is there a reason the M was used as is that the index or the exponent?
It's both. Yeah, it's a that I would say that that's both. It's an index you being used as an exponent in the place of an exponent. So it is both. I think just to have another, just looking for other variables, right? That we don't really like to use I for index, I guess, and we were using N for numerators. We couldn't use N for index like we do other places. So you just sort of do the best you can to use the letters in the best place.
No, that's fine. I just didn't I didn't know if there was a meaning that I just didn't know,
No,
because there's a lot of
there's no
I don't
hidden
know.
meaning to the M. I know there's a N for numerator and D for denominator makes you want to go, well, what does M mean? And it really didn't mean anything. So well, thanks everybody for being here, and we look forward to seeing you back next week and looking at the games and activities that we'll have then. In the meantime, email us if we can help you in any way.